All right, guys, so this is 2.5, reason using properties from algebra. So the beginning part is going to make perfect sense. It's stuff that you just did from Algebra 1, just using some reasons. And the second part is the introduction to proofs, which it's just an introduction, nothing big. Pay attention like crazy, write down what I tell you to, and that should go pretty smooth. But it is a little bit difficult first time through. All right, here we go. Okay, so here's your properties. So reverse PEMDAS, that's what basically this page is, you know. So if you want to solve for x, you work backwards with PEMDAS, and this page here is nice to know, but in all honesty, don't put any of this in your notes. Let's just go to the next one right here, and away we go. So here's what I want you to do. When you solve these algebra problems using proof, here's what you do. So you have 2x plus 5 equals 20 minus 3x. Okay, so this would be your statement. This would be your reason. Since this equation was given to you, you write the word given to start the problem. You always write the word given when you start your proof. All right, and then we do one step at a time. Now, it's actually almost better if you don't show work because it cleans it up a little bit. But let's just say here, you know, I'd ask you, what would you move first? So there's x's on both sides of the equation. Hopefully you would say, well, you'd move the negative 3x to the other side by adding 3x to both sides. So I'll show my work here. I'll probably end up erasing it a little bit to clean it up. But you would get this. You'd get 5x plus 5 equals 20, right? So you'd say, well, how did you go from the first step to the second step? You added 3x, right? So then you can just put add. You can put addition if you want to. I'm not too particular on that, so just put the word add. And if you know, like I said, you could clean that up a little bit by taking that out, but you know, it's fine if you leave it in. I say I messed this up a little bit. That's fine. You know, just leave it in. Plus 3x. Okay, here we go. So the next step in solving for x, you want to isolate the x. So you want to reverse the PEMDAS, guys. If you reverse PEMDAS, you look for adding and subtracting. We are going to subtract 5 from this side, subtract 5 from this side, giving you 5x equals 15. So then you'd say, well, how did you go from the previous step to what we just did? You subtract it. All right. And then the last step, you divide by 5, giving you x equals 3. Because we said the word divide, that'll be your final one. Like I said, it's not too bad. Just Algebra 1 last year. Quite a bit of review. You're just stating what you did. And here's the next one for your notes. We got all right, so once you got it written down, statements go here, reasons go across. Since they gave you that information, this is called the given. Ready? Okay, so the first thing you'd have to do in this one would be distribute. So you'd go negative 44x. And you guys remember distribute is, you know, drawing the arrows, right? Minus 8 equals 80. We distribute. Next step, you'd add 8 to both sides. Okay, so I'm not going to show my work, but you know, well, I can throw it out. That's not a big deal. Add 8 equals 88. Like I said, if you leave it off, it cleans it up a little bit. I just hate to have you get it wrong because you didn't show work. So we added. So that'd be our reason for that guy. Divide both sides by negative 44. Divide would be our answer. Okay, there it is, guys. Okay, so most of your homework will look just like that, which really isn't too bad. Just an Algebra 1 review. Skipping this one, a little bit tougher, but a good one to go over. A equals 1/2 BH. Now we're going to solve this one for the letter B. Okay, so here's what we want to do. We have the given. To start off with, if you're going to solve for the letter B, you move everything but the letter B. In between the 1/2 and the B is multiplication. In between the B and the H is also multiplication. Whenever you have a fraction as a coefficient, the thing to do is to multiply by its reciprocal. The reciprocal of 1/2 would be 2/1, or you could say just multiply both sides by 2. So if you multiply both sides by 2, and I'll just put it right here, here's what will happen. You'd bring down 2a equals the 2 times 1/2 equals 1, and you can leave it off, bh. So what did we do on both sides? We multiplied. The last step in solving for b is dividing this side by h, giving you 2a over h equals, that cancels, b, and our last step is divide. All right. Okay, guys, so here's what they're talking about. So this is the beginning of the proofs like I talked about earlier, and there's reflexive, symmetric, and transitive. And of this, here's what I'd like you to put on the board. So I am going to try to get this out of the way, and I'm going to shorten it up here. Okay, so if you need to, go back, but I'm just going to write down what you need for your notes. We'll try to save some time. So the first heading is reflexive. And when you do proofs, typically, you'll have segments or angles. Okay, here's what reflexive looks like if you're dealing with segments. You'll have one segment equal to the other one. So reflexive is one side's equal to the other side, which really doesn't make sense now, but as we go through proofs, it'll make more sense as we go. Okay, so an angle is usually just one letter, like angle A. So put the measure, that's what M stands for, the measure of angle A is equal to the measure of angle A. Okay, so that covers reflexive. The next one is symmetric. Okay, we'll have two of them again. We'll have a segment and we'll have an angle. Okay, symmetric is being able to flip. So let's say you had a segment like segment AB is equal to BC, comma, then, now we could flip those around and it doesn't change anything, like BC is equal to AB. Just flipping them around, that's all you're doing. Same thing with the angle, you just flip the angle around. So let's say you start with the measure of angle A is equal to the measure of angle B, then just flip them around. The measure of angle B is equal to the measure of angle A. All right, let's see if I can scroll down a little bit here. Okay. All right, and the last one is called transitive. Again, we're typically dealing with segments or angles. Okay, so transitive starts with, let's say you have segment AB, and that's equal to BC. And you also know that BC is equal to DF. All right. Then we have a comma, then. Here's what we can conclude. Okay, guys, so when you read this to yourself, it says AB is equal to BC. BC is congruent to DF. Do you see how the BC repeats itself? Right here. See how the BC repeats itself? Now, don't circle it because you'll mess up your notes. But if I do this and I cross them off, here's what you'd have left over. Do you see the AB is left over? and the DF is left over. So that means AB must be equal to DF. That's what you can conclude. So transitive is, looking at two different statements, noticing that two things repeat, and then canceling them out. All right, so angles. Let's say you go with the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C. Then, okay, so if you read it back to yourself, you'll notice the middles. They both have an angle B in, right? These two right here, angle B. Okay, so you cancel those out, and then you'd say, well, what do you have left over? Angle A is congruent to angle C. Or equal to the measure of angle A is equal to the measure of angle C. Okay. All right. And finishing it off here. All right. So this is a full blown out proof, guys. So just bear with me and away we go. But do please put this in your notes. All right. So statements, reasons. So you're designing a logo. We are trying to determine that angle EBA, angle EBA is congruent or equal to the measure of angle DBC. So that's our finish, guys. We are trying to prove that. To start it, we look at the diagram and we pick out the information that they give us, such as the two red arcs. You see the red arc on angle 1 and angle 3. That's something we can make a statement about, like the measure of angle 1 is equal to the measure of angle 3. Since that was on the diagram before we started, that's given to us. All right. So in the end, we want to prove the measure of angle EBA is congruent to the measure of DBC. So let's make a statement about the measure of angle EBA. I can see already I'm going to have to move this over. I think I'm going to get a little bit more space here. Let's bring it over a little bit. Bring it over there. Okay, all right. So EBA starts at E, goes to B, finishes at A, is made up of two smaller angles. It's made up of the measure of angle 2 plus the measure of angle 3. If you put those two together, you get EBA. Let's make a statement about the measure of angle DBC. DBC starts here, goes to B, finishes on C. Let me erase this here so it's a little bit easier to see here. All right. So that's made up of angle 1 plus angle 2. Okay, so now we need a reason. So when we started, the first one is always the given because that was on the diagram. These next two, we're adding angles. So this is called angle addition. All right, so that's done. Now, as we start and we work our way down, we're getting closer and closer to proving this, that those two are equal to each other. So here's what we know. We currently know that the measure of angle 1 equals the measure of angle 3. So in other words, they equal each other. They can replace each other. So what I want you to do is look how this first one has the measure of angle 3 on it right here. Guys, we could replace that. We could take the 3 out and put the 1 in place of it. Last year we did it all the time with numbers called substitution. We're going to substitute the 1 in place of the 3. So here's what it would look like. The measure of angle EBA equals the measure of angle 2 plus the measure of angle, and now it switches from a 3 to a 1. Now because we substituted the 3 for the 1, that's our reason. And the last part. If you check this side out, they're identical. And on the previous page, I'll go back a page, hopefully we see it at the bottom, that transitive, remember when two things were alike, we crossed them off? Okay, so here's what we have. You guys, go back. There we go. You see this part, how you have angle 1 plus angle 2, and the same thing on the bottom here. It's just reverse order. This whole thing just cancels out. So we can put the measure of angle DBC, board's going a little crazy there, is equal to the measure of angle EBA because of transitive. All right, moving on to the next one. And this is the last one. All right, so here's what we want to do here, guys. We want to put a 2-column proof. Now, I got to put it over a little bit so I don't have space here. So there, statements, reasons. All right. Okay, so, and make sure you put the diagram that goes with it. Otherwise, this problem isn't going to make sense. So make sure we get this diagram in our notes too. All right, guys. So in the end, we want to show that AC is equal to BD. So we're done when we have that at the bottom. In the meantime, to start us off, it says AB is congruent to CD. Now, you might have noticed that from the red tick marks over on the right-hand side here. Okay, so that's how we'll start. AB is congruent to CD because of the given information. That information was given to you. Okay, so eventually we want to work toward this. AC is congruent to BD. So let's make a statement about AC. And this is where students, they start catching on a little bit where, okay, so you notice AC. AC is from here to here. It's made up of 2 smaller segments, like AB plus BC. AB plus BC. Let me erase this so it doesn't look so rough. There we go. Okay. All right, so we got that one done. Let's make a statement about BD right now. BD is made up of 2 smaller segments as well. So if we go from here to here, it's made up of BC put together with CD. Now the last one on the previous page here was called angle addition because you added 2 smaller angles. On this page, we're adding segments. So this one's called segment addition. Okay. So we're getting there, guys. We have the stuff listed on the left-hand side over here. The AC and the BD over here is where I'm talking, over here. Okay, so we're getting closer. So now let's apply this rule right here. We knew from the beginning that AB can replace CD or vice versa. You know, they can replace each other. So let's look at the very first one here. We got AC equals AB plus BC. So I'm looking at this guy, this AB, and I'm saying, you know what? I could rip out that AB and put CD in place of it. So it looks like this. AC equals, okay, now we're going to take out the AB and put in the CD plus BC. So we took something out, we put it in place of it. That's called substitution. And we're ready to finish it off. Check out what you notice about these 2 things. They are identical. See the BCs and the CD and everything's the same. So if everything's the same, you just cross all that off. Here's your final answer. BD equals AC, or you could just list, AC equals BD. So it looks more like the answer. So it looks more like this, Okay, so we need a reason for it. We just cross things off because they're equal to each other, and that's called transitive. Okay. All right, guys. So it's a lot to take in, especially since, I'm not here. And, come with your questions tomorrow morning if you got them. And other than that, though, most of the lesson does look like the algebra problem. So, all right, good luck. Have a great day.